Hi, everyone. Welcome to our Lunar Delivery Challenge webinar. We are going to give everyone just a moment to join the call and make sure their audio is connected. So we'll wait 1 or 2 minutes before starting. While we're waiting, as you're joining us, we'd love to know who you are and where you're calling in from. So please message in the chat, let us know where you are in the world, and say hello while we give people time to jump on. Tracy, whereabouts are you at the moment?
I'm in beautiful Orlando, Florida.
Orlando, Florida, a little warmer than Vancouver, Canada. I see someone else calling in from Texas. Kevin, whereabouts are you?
I'm in Yorktown, Virginia, near Langley Research Center.
Great. Okay. I see Texas, India, people from all over. Welcome. We are very excited to have you. So we're going to go ahead and get started. We will kick it off with some introductions and you can meet the great team that's on the call today. After that, I'm going to pass it over to Paul Kessler, who will share a short presentation on the Lunar Delivery Challenge, and then we'll go into a Q&A session. If you have questions, please post them in the Slido link. I'm posting that in the chat now, and I'll post it a few more times throughout the webinar to make sure you have it. So as we're going through, please put your questions there and make sure you're voting up your favorite ones, as we'll be, for the most part, working down the list. This webinar is being recorded, so we will share the recording out with you on the challenge page after the call. With that, we will move into introductions, and I'll start with myself. My name is Kyla Jeffrey. I'm the Vice President of Customer Success at HeroX and based in Vancouver, Canada, and I've had the great pleasure of working with this team at NASA through the design and execution of their challenge, and really excited for you all to get to meet them today. Kevin, I will pass it over to you.
Oh, you want Paul or anyway?
Just for an introduction.
Okay, yeah, I'm Kevin Kempton from the Langley Research Center. I've worked a lot of related things like this, namely LHAT Morpheus, a lunar lander on the lunar lander system. I've also worked the Ares 1X rocket, and I recently helped with some challenges. You guys, some of you may be coming from the ALGO challenge, or the Advanced Lightweight Lunar Gantry for Operations, which was a GrabCAD challenge. So hopefully some of the participants are in from that. And so this is a very important topic for NASA. We're just now getting started with the landers, and we really want to get these capabilities in sort of concurrent engineering. We don't know all the answers, but certainly you guys could provide some concepts that will feed back to the landers, and we'll iterate on that design. So glad to be here.
Great, thank you so much, Kevin. Tracy Gill, I will pass it to you.
Thanks, Kyla. Yeah, my name's Tracy Gill. I'm from the Kennedy Space Center. I have a background working on payloads from the Space Lab program to the International Space Station. And these days I'm supporting Artemis. I've been supporting Gateway and Gateway Logistics and some of that planning. And more recently, I've been involved in the human lander systems, and now we're helping to flesh out the ideas for things we're doing on the surface with surface systems, and working with Paul and Jamie and Kevin on these concepts. So looking forward to hearing from you guys. Thanks.
Great. Thank you so much, Tracy. Okay, Jamie, are you there?
I'm here. Can you see my video?
We cannot see your video, but we can hear you.
Okay. Yeah, so hello everyone, my name is Jamie Gomez, and I work with Tracy Gill and also Paul Kessler, and I'm stationed in Kennedy Space Center and mostly work in lunar ground operations as the assembly and integration discipline lead for HOS, and also helping out with lunar systems.
Fantastic. Thanks, Jamie. And your video showed up right as you started talking, so Zoom's watching out for you today. Paul, I will pass it over to you for an introduction, and then you can dive right into your presentation.
Hey, yeah, thank you, Kyla. Hi, my name's Paul Kessler. I work at NASA Langley Research Center. I work for the Space Mission Analysis Branch, and we do a lot of early, prior to projects being launched, early design, concept design, analysis, mission analysis, architecture trades across the whole gambit. I work for all the Moon to Mars stuff. I've worked on Mars teams. I've worked right now currently for the lunar architecture team. And I thought while we were going through some of our analyses that it would be really nice if we had an opportunity to get the inputs from the American public. There's a lot of people out there with a lot of different skill sets. And it was great. STMD, the Space Technology Mission Directorate, offered that opportunity. And here we are today. So I'm going to kick this off and give you a little bit of a presentation. And I hope you enjoy, and I look forward to seeing your ideas. So let me see if I can share this. Okay. All right, so welcome to the Lunar Delivery Challenge webinar. If you're here today, it's because you have an interest in exploration of human exploration of the solar system, and you want to contribute to that. And I'm really excited to have you here. I'm really excited to see what you come up with. And this is a very critical component to sustained lunar presence. This is a component that is very important also for sustained presence on any other planetary body. So it's something that is near and dear to my heart, and I think many others, especially at the agency. So let's get going. Let's talk a little bit about the Artemis program first. We have a plan, an ambitious goal of landing the first woman and the next man on the moon by 2024. And as you know, back in the day when Apollo was going on, we were going to do this and then we were going to go away. But we're going to try to do this, and we're going to have a sustained buildup, and then we're going to go from there and leverage that to get ourselves to Mars. So prior to that 2030 timeframe, after 2024, we're going to start trying to create that sustainable base camp that we can stay there, survive, and thrive on the moon as much as possible to learn the lessons that we need to learn so that we can thrust ourselves off to the next destination. So our base camp is going to serve as a hub for scientific research, and it's going to be a base for that Mars exploration. So what does Artemis need? Artemis needs things on the lunar surface. We need to deliver those things on the lunar surface, and this is where you come in. We have to have cargo that's delivered to the lunar surface for a lot of these missions. It spans more than one landing, and that cargo needs to be offloaded from the lander. It needs to be a robust and reliable handling technique, because on the lunar surface, we don't want to drop expensive hardware and expensive goods and just destroy them. We want to make sure that we get them there and we get them there reliably. We want to make sure we get them off those landers. And let's see here, things are getting in my way here. All right. And we want it to be compatible with a broad array of lunar lander configurations. You can imagine we're trying to get lunar delivery services procured for NASA to actually achieve its mission. And over time, not only NASA, but the commercial industry, as it is kicked off, we are hoping that we will have these same concepts that are applicable to other types of landers, and they can span a broader array. So let's give a little bit of context. We have been developing concepts at NASA for doing just this thing. We've developed some prototypes as well. Now, while these methods are effective at some operations, we recognize that there are opportunities that maybe we aren't seeing. We recognize that there's a lot of challenges on that lunar surface, and there's a lot of challenges to getting that cargo off landers and onto other mobile devices or onto the surface itself. So we recognize that our concepts may not be totally optimized for cost, mass, or even that simplicity. And so that's why we're looking to you. So the ask, what are we asking for? NASA is seeking ideas from you, the public, to be a part of this great and ambitious mission of exploration of humans across the solar system. And you're going to do this as the public, bringing your ideas to the table so that we can take them and we can use them. And so we're interested in taking those and incorporating them into the trade studies that we're already doing. And we're going to try to move through that process to try to develop them further so that we can have a successful sustained presence on the moon and beyond. So who can participate? Really anyone. And this is the beauty of it. Anyone age 18 or over, that from any background. So you may have background in other things that aren't space related. We recognize this. And while NASA engineers come up with a lot of great ideas, we recognize there's other people out there that have great ideas too. You might be that person sitting in your room that you thought of that wonderful innovation, that wonderful new idea, and you said, man, if I just had an opportunity to do it. The door is here, an opportunity is knocking, and it is your opportunity now to jump in and get into this game. Now you can sit there on that couch and you can just think up all the ideas, but we're giving you an opportunity not just to think up all these ideas, to develop them, to hand them over to NASA engineers for them to look at them and have the opportunity to win prizes and get your ideas moving forward. So what kind of things are we going to be offloading? Well, as you can imagine, when you're thinking about across a large architecture, a large sustained human presence, there's going to be a number of things that we are going to have to consider. So we have small class things that we would consider, and that would be in the areas of maybe power cables, batteries, the little equipment that we think about all the time, even some small science packages. Then we've got a little bit more mid-size areas that we're concerned with, the 2 to 8 metric ton. These are things anywhere from refrigeration systems, food production plants, and even all the way up to habitable mobility platforms. These are platforms that are really, they're really rovers, they're pressurized rovers. Because it's one thing to get to the lunar surface, but you want to be able to explore the lunar surface. So we need those pressurized rovers down to the surface. And then the other bigger things that we want to have is laboratories, medical facilities, habitats, anything that we need to land of a larger nature in this 8 to 12 metric ton frame, range gives us that opportunity to really hunker down and have that sustained presence that we can operate out of. So you can see some of the examples of the payloads here listed, and there's some links in it, and we will provide this this presentation to you, and you can read a little bit more about it. And it's also been on the website as well, so you can learn about the Lunar Terrain Vehicle, and you can learn about the Lunar Surface Sustainability ConOps. But one thing that we want you to keep in mind overall is that we want you to also think about and consider the interfaces and standards that will make compatibility possible to a variety of different payloads and landers. Because as you can imagine, with such a wide variety of things that need to be offloaded, there's going to be a lot of interfaces that we're going to have to think about and how that's going to be best done. So we would ask you to also consider that in your proposals. All right, so this is just kind of an example of the start to an initial base camp, where you see here in the background, you've got a habitat that serves as the foundation for operations. You see this habitable mobility platform, this pressurized rover, where it's like taking your camper and it's going out into the field. You can get a lot longer distances. You can go and do a lot more exploration and see a lot more. And then you've got your lunar terrain vehicle. I mean, everybody wants a dune buggy. Why not on the lunar surface? I mean, that's amazing. And so as you can see, these astronauts are going to need to be performing lots of work. They're going to need to be doing a lot of exploration. And it's to help build up not just the scientific stuff that NASA has always done that we want to continue to do, but it's also an opportunity for those astronauts to find things that may be commercially viable, that may actually build and blow up and make our economies much, much stronger. So let's think about the landers that they're coming on. Now, we do have a wide variety of landers right now. There's a lot of bidding processes going on, and there's different size landers you can consider. Now, there's probably gonna be questions related to, do I have to offload off of every particular lander type? No, that's not necessary, but it would be good to know how well can you maybe formulate this to work on more than one type of lander, and how many landers could it work on, or is there any limitation to that? So we consider the basic 3 ranges of landers that we're talking about is about the 0 to 4 meters off of the surface, and then you got the 4 to 10 meters, and then 10 meters and above. And one of those proposers is extremely high off the ground, and some of you have already asked about it, is, for instance, would be Starship. And so there's some nuances there and some things to think about there. But you should decide on your solution and consider that a single height range, if it's limited to that, that we just know that it is. And if it's really versatile, how versatile is it? That's really the important thing. So as a part of this in delivery services for the lunar surface, NASA has also put out the Commercial Lunar Payload Services program. And in that, we are trying to secure services to deliver a lot of these things. So your offloading device may be utilized on one of these types of landers, not just the bigger ones, but maybe smaller ones. So that's why we have such a wide range. We want to be able to see particular concepts that would be interesting to use, that we could hopefully employ in multiple ways. And of course, all of these links are already found on the presentation, and we have a lot of these on the website as well in the documentation. And then we have this human landing system. You can see the tall SpaceX Starship sitting on the lunar surface, offloading, in this case, having this lift system that's dropping people to the surface. And then we have the more what we would call a lower slung Dynetics type lander. Everything is much, much lower to the surface, or this just this standard version that we've seen in other areas, like even in the Apollo missions from the national team, where we have a little bit higher lander, but not real close to the surface. And then finally, we also have, along with the services for delivery on the lunar surface, as well as the humans to go to the lunar surface, we have gateway logistics that we're providing to the gateway. The gateway is that orbiting platform that is being developed right now to go and be around the moon as a base of operations to the lunar surface and beyond. And the gateway logistics services is to help facilitate some of that as well. And so there's opportunities there potentially for those same types of offloading devices to be used in multiple ways. But this is just another example of the type of things that we as NASA need to do across the architecture. So some other considerations that you need to have in mind when you're doing this. You have to think about the pros and cons of the landing capability for each payload, or reusing across the architecture with dedicated landing. So what I mean by that is, if you are going to take your particular offloading device and manifest it or put it on the lander with the actual payload, that's fine, but you need to think, am I going to do that, or am I going to allow even more versatility? And in order to accomplish that, I need to have a dedicated landing of my offloading system, because it has to have the mobility, it has to have all these other things, or it needs to attach to mobility, and I need that mass that's just not available to me with the payload, or maybe some combination thereof. So that's something else to consider. You also have to think about the payload access location and elevation from the surface. We haven't defined this for you purposefully because we don't know what that is. And making assumptions is going to be a part of doing this concept design. And those assumptions, as you walk through them, you can help us to understand why you've made those assumptions and what that really means in terms of your offloader. Because quite frankly, this could be a primary driver. We also wanted you, as I said earlier, we want you to consider payload handling interfaces and standards. If you look at any offloading that's done on Earth's surface, we have a lot of different standards for how that offloading is done, how things are carried, how logistics are done, and how they're offloaded. And remember, this is being done by machines or capabilities that are outside of the human element. If you're getting an Amazon package today, you're going to use a human. But in this case, we're talking about uncrewed, crew-tended vehicles that are offloading things. But that doesn't mean that those systems are limited to only being offloaded without crew, because there's certainly opportunities that they could probably facilitate crew as well. Then we have to think about the mission-specific lander configuration that may drive our design. So you're going to have to make an assumption when you're thinking about what type of lander, how is it configured, where is its deck, how do I access those things? And that's going to be a part of it. And Also, for your particular designs, is there a modularity component to them? Do they evolve? And is there some path to evolution to something that is more capable than it was maybe before? If it's a one and done, that's fine. If it's something that offloads and then it can be repaired with something else and become utilized across the architecture, that's also great. But it's not, nobody has to take one track or another. It's an opportunity. Finally, we have our judging criteria. You can see here we talk about reliability and feasibility. It's extremely important that we can do this reliably and feasibly on the lunar surface. Now, we recognize as aerospace engineers that work on the lunar environment stuff, you may not have all the ins and outs about the space environment, but understanding that the system that you have is not overly complex, but it has that ability and that reliability to actually offload the stuff on the surface correctly and without damaging anything. You also have to think about mass and volume optimization. How are you using mass? How are you using volume? It costs a lot of money to send anything in terms of its mass and volume into space, and it's going to cost a lot of money also to bring it to the lunar surface. So we want to try to optimize as much as possible in this area. Another area is autonomy. We want to be able to do this again without having crew available. And we also want to make sure that we can understand your proposal, that it is clear that you have made some assumptions and that you have clarified those assumptions, and that your proposal quality is good, because that's important for us in order to judge that. And then another aspect that's on there is the flexibility of your design. Is it flexible enough that we can change its size a little bit, we can put it on a smaller vehicle or anything like that. And then finally, its applicability to the lunar surface. We want you to consider that there will be some challenges with regards to the lunar surface. Will this system be applicable on the lunar surface, or is it going to start to run into major issues? So if you have that knowledge, it's great, bring it to the table. But you can see where we put most of the weight of our criteria and where some of the weight has kind of gone down a little bit more. So I really encourage you, just bring your ideas to the table, really flesh those out and put those in front of us. All right, so here's the other great portion, is there's monetary prizes for this, right? This challenge has up to $25,000 in total prizes for up to 6 teams. The first place team, the first place winner, could receive up to $10,000, and we have 2 second place winners receiving $4,500 each, and then 3 third place winners receiving $2,000, all US dollars here. All right, other prizes. Well, outside of monetary prizes, you get an opportunity to present your concept to NASA engineers. I think that's pretty amazing. I mean, if I had an opportunity to take my ideas to somebody else that might actually take them further on and they become something real, that sounds pretty exciting to me, especially if I can take that and I realize that somebody likes it and I can present that concept and get some feedback. I could further develop that concept for myself, maybe even make my own business out of it. Also, another thing is, pending our availability, we want to try to have a conference or a virtual event for the prize winners to present and interact with NASA. I know that during the shutdowns in a lot of the countries that you're in and I'm in, is that it can sometimes be a little bit difficult to try to organize something like that. We're going to work on trying to get something like that together. Also, getting the publicity of having your concept announced as a winner from NASA, from HeroX. I mean, I think that's a great idea too, because again, you're getting your name out there, your concepts out there, and your ideas. They're important. Also, a wide promotion of this on social media as well. So this is really about all of that publicity that you get. And then you also get a participation in a webinar showcasing all the winning solutions to the public. And so we really look forward to something like that. All right, so after all that being said, hopefully you're jazzed and you're ready to go and you're excited. Is there any questions that you have? Let's go ahead and go to that.
Fantastic. Thank you so much, Paul. So we are really excited to take questions from everyone on today's webinar. If you have questions, I have just shared the link for you for where to put them in the Zoom chat. So please open that up We are using a tool called Slido, so you can add your questions directly into Slido and make sure you vote up your favorites because we'll be prioritizing those questions that have a lot of interest from the folks on the call today. Just before we jump into questions, I want to share briefly about the challenge page on HeroX. So this is where you should go for any information on the challenge. All of the great details that Paul shared today are also in this challenge under the guidelines section. So this is your place to go for information. If you have questions following the call, the forum is the place to go for additional questions after today's call. When you sign up for the challenge, you'll click the Solve This Challenge and be taken to the challenge-specific agreement, which you can have a read through and accept, and then you have some options for joining a team. There are some eligibility restrictions that you should be aware of, and you can see those in the legal agreement I just shared. And there is a summary of them, or of some of the key ones, on the Guidelines tab. So there are restrictions based on whether you are a designated country or from a designated country, and you can follow this link here to see if your country is listed as designated. If not, then it just needs to be substantially transformed in the US or a designated country prior to submission. This is a new requirement for our NASA challenges. So if you have participated in NASA challenges on HeroX before, this is a new requirement. The other eligibility consideration I'd like to share is also that you need to make sure that any release or transfer of technical data to non-US persons complies with ITAR regulations. And again, you can see more details following that clause number. But the place to go for the full information is in the legal agreement, and this is just a high level of those eligibility considerations. Okay, we are now going to switch over to the Q&A. I am going to go off script. I told Paul and Tracy and the team that I would let them know ahead of time if we were not starting at the top question, but I'm going to do it anyway. So we had a lot of questions in the chat about the metric tons for the payload categories and whether that is the mass on Earth, the mass on the moon, how that relates to gravity of the moon, what is gravity on the moon. Can you just give us an overview of how those things connect together and what people should be aware of?
Yeah, so when we're talking kilograms, we're talking about it outside of a gravitational field, right? When we're thinking about newtons is when we would think about it in terms of a gravitational field. Otherwise, like pounds, because it's I can see the confusion because oftentimes we see when we're doing I don't know, when I go to the gym and I'm lifting weights or something like that, I might see kilograms on the side of that, and I think, well, kilograms, that must be a weight, but it's really, it doesn't matter about the gravity environment there. So it's on the moon, of course, we have 1/6 gravity, but 60 kilograms is still 60 kilograms on the moon, but 60 pounds is not 60 pounds on the moon. So that's where the confusion is. So I hope that answers the question. Did you have anything else to add, Tracy?
Yeah, I was just going to clarify it. So yeah, there was a lot of questions about metric tons. So the metric ton measurement is the same, as Paul said, on Earth as on the moon. So it'll make no difference from that perspective. We want to be able to handle that mass on the moon.
Great. Thank you so much, Tracy and Paul. And if you still have questions, please add that in, but hopefully that clarified those questions. Okay, so we'll start at the top of Slido. Do the landers eject out of the payload, or is the solution to reach into the cargo bay and unload the cargo?
I'll let you answer, Tracy, because I've been talking a lot. I'll let you go.
That's fine. So that's a good question. So I think, as Paul said, there's a variety of landers. So what we want to be able to do is to remove the payload from those variety of landers. Now, we don't want to eject payloads off a lander because that could be a little bit unpredictable. So we assume the lander is going to land, the payload will still be installed in some fixed manner, and then we'll want to remove it. Now, whether that payload is installed on the bottom or on the side or on top or how high, those are all variables, and you can make assumptions based on maybe the flavor of landers you might have seen in some of those images there, where they may have low slung payloads or payloads mounted on top. So you won't be getting payloads kind of pushed out. you'll want to be able to grab them from different approaches, above, below, or adjacent. So those are all kinds of things that you'll be able to think about and have some flexibility. And then, of course, make some assumptions and state what they are so that we can understand what you've proposed.
Great. Thank you so much, Tracy. Okay. Next question, and I will share my screen on these so you can have them in front of you as well. What are the dimensions of the cargo bay for the landers? Paul, do you want to take this one?
Yeah, I think again, this is something that's undecided, right? You're just gonna have to make the assumptions, and then you're gonna have to outline that for us, what you think those assumptions are and what they mean. The easiest thing would be to assume that it's an open deck rather than having a cargo bay. That would probably be the easiest thing. But if you want to consider something like a cargo bay, you can make some assumptions. You can look at things like the Starship and say, hey, let's make some assumptions based off of this cargo bay and how we would offload things. But I would go as a first step, probably just try to keep it open a little bit and not worry so much about cargo bays. But if you have a particular technique that is very capable of getting things out of smaller spaces, go ahead and actually show that.
And let me just add that, there's more than just 3 possible landers. As we showed the 3 possible landers from the Human Landing System competition, there's also the landers that are qualified providers for the commercial lunar payload services. I believe there's 14 right now. So those landers could have a lot of different capacity for payloads, whether they're on top or on bottom or on the side or in some sort of cargo container. So it's more than just 3 landers for sure. That's part of the challenge of this, is that there could be a wide variety of landers, more than just 3.
Yeah, there's one other thing I want to just emphasize a little bit, is that we are in the early concept phase of development. And so naturally you're faced with a lot of questions without a lot of clear answers, and you're forced to make a lot of assumptions. But we've tried to give you as much as we can in order to help facilitate that.
Great, thank you so much. Okay, what are the payload volume and dimensions? Would it be helpful if I share my screen on the payload categories for you to answer this question?
You could do that. I think you could also just use what's open source and out there and what you assume might be the type of landers. If you think about the landers themselves, or you look at a rover and it's sitting on maybe a 4-meter diameter deck or something like that, you would have to assume that it is probably less than 4 meters, and you can make some assumptions. A lot of this is done by engineers by reverse engineering. You go and you grab some pictures off the internet of things that you see, or use the links that we've given you, and then make some assumptions and just go with that assumption. We're not expecting exact details here. We're not expecting decimal precision in terms of mass. We're not expecting decimal precision in terms of height and width and volume and things like that either.
Great, thanks, Paul.
If we think back, I was going to add, if we think back to the slide deck that Paul showed, and we had the chart there with the 3 different categories, and then the following chart that showed the 3 different, very, very different kinds of payloads, with the lunar terrain vehicle and then a pressurized rover and a habitat in the background. That's why, because the payloads can be of such a wide variety, that's why it's difficult to put constraints on the payload volume and dimensions, because we want to be able to discuss that gamut, the whole range of payloads there, from small to large.
Great, thanks, Tracy. Okay. SpaceX. Does SpaceX plan on lowering the cargo? Can you talk more about their solution and how this impacts maybe potential landers for here, potential unloading systems?
Go for it, Tracy.
Yes, if you saw the SpaceX image that was in this package, and if you went and did some research on Starship, you can see that it looks like they have a kind of an elevator that goes down the side, and they plan to put their payloads inside and then lower them down to the surface. But even if they do that and do all that steps, it'll still be sitting there on that platform, and we'll still have to grab it and get it off of there and move it somewhere. So just because one particular company plans to do it one way, we want to have solutions that will work for not only that one company, but for other companies and other landers as well. So, don't be too concerned about what the images you see and the concepts you see from any particular type of lander. Think about, things that are common that could be applied for a variety of landers, because that's really, as we get to the sustainable architecture and we have multiple kinds of landers there, that's when we really succeeded in what we're trying to achieve with Artemis, and having a kind of sustainable concept where you have a pipeline, of a logistics pipeline where you can supply it, and there's multiple providers. That's kind of what we've done starting with the space station. We kind of, we started with a couple providers, and we still have a couple providers, and we're adding more. And that's where we want to head with the lunar services, and then of course take these concepts onto Mars.
So Tracy, there's a question further down that I'm going to jump to while we're on this topic. Do teams need to design their solution to work on all the different landers? Can they select one to optimize for, or multiple to optimize for? What are you looking for here?
Yeah, that's a great question. You have some latitude there. So you may decide that you want to optimize a solution for a particular kind of lander, maybe a particular elevation where the payloads are located, because you have a really good way to do that, and it seems like a practical thing to do. Well, then just state those assumptions and let us know why you're choosing to do that and how it would work. Alternatively, you could propose a solution that applies across a wide variety of landers and tell us about how that works and state the assumptions that go along with it. So we're not going to be prescriptive about how narrow or wide you want your focus to be in your proposal. So we'd really like to see, proposals of both kinds.
Yeah, and honestly, just to jump off of that a little bit more too, in order to be competitive, we're not pushing you in towards that category of you have to be able to go and do multiple things across the architecture. It's an option, it's a flexibility, but and that could be flexibility to other lander types. I think what we have found is a lot of times when you can do everything, it's kind of like the way I see Bowflex or something like that, not to pick on Bowflex specifically, but you get a machine that does everything. It usually does everything fairly well, but if you had a bunch of different machines doing things, they can do things very, very well. And there's a cost to it. So there's a cost in terms of its capability, and there's sometimes a cost in terms of its total mass to surface.
Yeah, I was just going to add also on scalability. Think about a development path for your unloading system. So if you have a scalable system, you may be able to test it on CLPS landers, which are much smaller payloads. But if it is scalable, then later on, as the larger landers with human scale payloads come, you've already have a system that's been tested at a smaller scale. It can be easily scaled up and work on these larger systems. So think about the development path also.
Great. Thank you all for that great answer. Okay, these next two questions I think we already addressed, and there's quite a few questions here, so I'm going to skip past them, but I'll just pause before I do. Paul, Tracy, Kevin, anything else you want to add about payloads, how those payloads are positioned on the lander, their size?
The only thing I could add is that there are some standards in terms of what they call cargo transfer bags, what we call CTBs. You can find those ISF's information. You can find that online as well. So there are basic standard sizes of different things. You should be able to find sizes of a lot of different things in terms of what might be offloaded. Aside from that, I think we've pretty much exhausted as much as we could say on the issue.
Yeah, I was just going to say, I'd mentioned earlier about the iterative process. And so in the commercial industry, there's a lot of grappling systems if you look at shipping containers and things like that. And so these lander and payload designers are just getting off to the design, getting off started on their designs, and there's no standardization. And what we're looking for, if you have some concepts that would allow some standardization, we'll take those concepts and then we'll communicate that to the lot of payloads and lander providers, and potentially we'll iterate on a good solution that can work for a large majority of the payloads. And so, yeah, these kind of things that are used in commercial industry could be great on the lunar surface if the other payload providers will move forward and start going to a standardized attachment fixtures and things.
Yeah, no,
Go ahead, Jamie.
all right, sorry. And I will just add that on the challenge website, there's under resources, there's a payload mass categories PDF that has a greater list of types of cargo you might see.
Yeah, and I was just going to add to further beat this one to death. The standardization aspect that is of great interest to us is the standards for attaching and offloading and grabbing, things like that. Not so much the putting the payloads into particular boxes, but standards that might be applied to different kinds of payloads. That aspect of standardization is very much of interest to us.
Great, thank you so much. Okay. Next up, how close to the unloading point is the lander going to land?
Yeah, the unloading point I would consider is right where the lander is landing. It's going to offload right there. It will either offload to another mobile system, or it'll offload directly to the ground. I think that would be the starting assumption here. And if you
Great.
want to take it from there, then you can, if you had something that was a mobile device.
Great, thanks, Paul. These questions are actually in great order because the next one is along the same theme as well. Can you talk more about the terrain between the lander and the moon base? Can we modify it? What is the surface condition like? So you just heard from Paul that it is optional to transport the payload once it lands on the moon. That is a desired but certainly not required feature. Paul, can you talk a little bit about the terrain?
Yeah, the terrain itself, obviously we're going to try to land on something fairly flat as it hopefully that's possible, and then when we land there may be situations where there might be hills or even some boulders in the area. Our ability to clear them out right now, we're just going to assume that that is not something that we're doing. Now, long-term sustainment is that we would do that. Depends on how you want to deal with it. If you want to consider them fairly clean or pristine areas that you're offloading on, you can make those assumptions. Just make sure that you document those. But I think ultimately we're talking about getting to the moon, and when we're there, it's not necessarily developed in terms of the surface.
Great, thanks, Paul.
Mm-hmm.
Okay, will the boxes be transported back to Earth?
I think there's opportunities for things like that to happen. That is not something that has been determined yet. I think the biggest thing to concern yourself with right now is the offloading portion, but there is that option, and I'm open to seeing what ideas come back there too. So there's no real clear answer, I know. Maybe Tracy or Jamie, you can give any other insights.
I'll share one thing before Tracy jumps in. So if you look at the guidelines, which really should be your go-to source when you have different questions, there's this section about additional capabilities that are desired but not required. So both of the two that we're talking about right now fall within that. So being able to load the payloads for return to Earth and being able to transport them. Those are, if you have an idea, share it with us, but it is not required. Tracy, anything you'd like to add, or Paul?
Yeah, that's just exactly what I was going to say. It's not our primary focus, but if you have a solution that's good at removing something from a lander, it's not much of a stretch to think that it could put something back on a lander that was going to ascend. But again, it's not our primary focus, but it would be an ancillary function to evaluate.
Great, thank you. Okay, how is the load secured in the lander? Would it be valuable if the load could secure itself in the lander?
I'll take a stab at that. Those are just the kinds of things we're interested in getting feedback on. Recommendations on standards for how to load things are, a high priority. We want to be able to see approaches that work for lots of different things. So, I mean, that's touching on something that we'd like to see in their proposals.
Great, thanks, Tracy. And just a reminder to everyone that you can go in and kind of vote up the questions you're most interested in. We're getting down to the questions that only have a few votes. So if there's one that you want to make sure we cover, make sure you vote it up so it gets to the top of our list. Okay, are loading or unloading operations only during periods of natural sunlight, or can they be extended using floodlights, etc.?
I think right now what we're assuming is that you would be doing loading, unloading operations during natural sunlight. Keep in mind that on the lunar surface, on the lunar south pole, which is where we're planning on landing, that the sun will be on the horizon a lot of times. So you will have large shadows that are cast on the surface of the moon, and it won't be directly above you. It won't be at 45 degrees from you. And there will be moments where there is darkness, but right now we're going to assume that you have sunlight while you're doing those offloading operations, but you can certainly supplement with floodlights if that's something that you feel the need to do. I think that as NASA, we'll probably have to consider that in all operations either way.
Great, thank you, Paul. Okay, what kind of repair tools will lunar team members be likely to have in case of a cargo transportation vehicle breaks down? Will they be able to fabricate parts?
I'll add a little bit on that. The team should consider their design to be as low maintenance as absolutely possible. EVAs, we've been on the space station for 20 something years, and EVAs are still not routine. They're extremely hazardous. And so you want to minimize any required human maintenance or operations on your systems. The ideal thing on the lunar base will be teleoperated robotics. And so if a teleoperated robotic can replace some maintainable items, that may be the way to go. But definitely limit human intervention. In the Game Changing Program Office, we have a little demo called the glove box, which is a clear acrylic box where you have astronaut gloves. You put your hands in and they draw down the pressure, and you have these gas pressurized gloves. And you realize once they get pressurized, it's very stiff and hard to move your hands. The tactility goes down, dexterity goes down. So don't think that the astronauts are going to be out there doing complex maintenance operations on your system, and try to avoid that as much as possible.
Great, thanks, Kevin. Okay, what about materials? Are there certain material restrictions that teams should be aware of for their design?
Again, I think that's, I'll take a shot at that. Again, I think that's something that's not our primary objective with this study. There are going to be material restrictions because of the environment of the moon, with the lack of atmosphere and temperature variances between being in the sunlight and being in the dark. It's going to be a harsh environment, but we don't want that to constrain the primary focus, which is kind of the mechanical and technical aspects of loading and offloading something. So those are things that the material refinement is something that could be worked out in a design maturation once you have this concept fleshed out. So I wouldn't let that bog you down too much. It's something that we're interested in, and it's something that you'd have to design eventually for if you were going to make something for flight. But while we're in this concept formulation phase, I wouldn't let you get bogged down by that. Does anybody else want to add anything to that?
Yeah, NASA has all kinds of standards on materials. I agree with Tracy that it's not the primary concern. We're looking for concepts, and you can work out the engineering on the materials probably pretty effectively, but certainly the environments on a lunar surface with the extreme temperatures. We don't want outgassing. Materials that outgas are typically bad because they could affect other systems, and flammability, pressure vessels, and things you have to be very careful with. But overall, yeah, don't go too far on the materials, and realize the material should be cost effective. That, lightweight is such a big deal at roughly $1 million a kilogram. So think about weights and stuff. If you really get into that level of detail, that's critical stuff.
Great. Okay. So this next team is considering using electronic controllers and the impact of temperature on them. What is the lowest and highest temperatures that they should be considering to protect their controllers?
Again, I think this is kind of the same discussion we just had. I wouldn't be too focused on that. If there's something that you're particularly interested in for your own refinement, NASA has a design specification for natural environments. The acronym is DSNE, which kind of sounds like Disney. And that's out there. It's available on the NASA Technical Report Server, and you can look it up. It has that kind of information in it, but that's not our focus for this challenge. We really want to look at the concept for getting the cargo off and on, and this is kind of down in that design maturation that would eventually have to happen. So I don't think we should get too bogged down with that.
Yeah, and I'll also add that typically if you have electronics, they're going to be in a warm electronics box that has a thermally controlled environments inside that electronic box, and except for maybe gear boxes and things that you really have to keep outside that would need to be heated. Yeah, the big factor on that, you can keep it to the right temperatures. The problem is the power required to keep it at the right temperatures, and so you're always looking for electronics that can survive cold temperatures as well as conduction cooled. But as Tracy said, that's a little bit outside. We can solve that problem. We've done a lot of thermal conditioning for electronics to make sure they stay within temperature ranges and part selection and things like that. So.
Great, thank you. Okay, the next question is asking about the prize purse and stating that it would normally cost several $1 million. So I think I just want to emphasize here that we're looking for conceptual designs. We're not looking for anything that would take that kind of scale. You actually do not need to be familiar with CAD drawings to submit to this challenge. We think that innovative ideas could come from anywhere. So if you are not an engineer by trade, but you have ideas and you can share those with us and convey them in a compelling manner where we can understand them, that is perfect, and you should absolutely submit to this. If you have the expertise to create CAD drawings and engineering drawings, you should submit those too, but they are not required. So we're really at the concept and ideation stage here, and the prize purse is in line with what we're asking for, given we're at that early stage.
Yeah, I'll add in also that I work in the prizes and challenges program on the side here. So, and the funding that we get to do these external challenges is very precious, and we like to do these kind of things because we really get some out of the box ideas. That the NASA community can be pretty small, and so these out of the box ideas can really pay big dividends with this precious amount of money that we use for these external challenges, and your success is going to be our success. And so if we can show the value of these external challenges, we'll be able to put on even more external challenges. And so we're really hoping you guys come up with some great ideas that we can implement.
Great, thank you so much, Kevin. Okay, the next question. If our project is not chosen by NASA, can we publish it to the media? The answer is yes, you can. Even if your project is selected by NASA, you are granting them a royalty-free license to use your submission, but you still maintain ownership of the intellectual property. So regardless of the outcome, you are able to share your idea as long as you're complying with any regulations that might impact that, like ITAR regulations. Okay, once the packed system lands on the moon, how will it be unloaded from the landers? I think that's what you need to figure out as part of your solution. Team, anything you'd like to add here?
Yeah, I would like to say that autonomous system is always great because essentially we're looking at the sustainability of the moon. So if the system's able to offload itself from the lander, it would be a great benefit. And essentially for this study, we're kind of looking at the unloading of the cargo, so it may not affect the rating as much. That's all I had. Is there anything else you'd like to add?
Great,
I think that was
Jamie.
good.
Okay, can we design a payload adapter that is compatible with our unloading device?
Yeah, I guess I could take that one also. So for the payload adapter, that would kind of be encompassed with the unloading device. So if you do design a payload adapter, we'll take that into consideration with the unloading device and how it unloads the cargo.
Great, thank you. Okay, I am going to say this next question is not relevant to the challenge. NASA team, anything you'd like to add here, or should we move on to the next one?
Nope, I think we can move on.
Okay. What are the power assumptions? Type, amount, can you share a little bit about that?
I think for us, it would be helpful for us to know what your power assumptions are in the sense of what sort of power loads do you need in order to operate your system. If that's information that you have, if that's not information, then okay. But if you have that information, I think it'll be incumbent on us to figure out how to, as we mature that design over time, what that looks like. And I think both that as well as the thermal, as well as the materials that we were talking about earlier, I think that's going to be a little bit more down the road. Right now, we're looking at those concepts. And if you have power assumptions in terms of loads that you would need in order to operate the device, that would be helpful information to include in your proposal.
Great, thank you so much, Paul. So we only have 2 minutes left, and we're down to all these questions that only have 1 vote each. So I'm just going to select a few that I think are most valuable, or maybe one for our last question. Then we'll do our best to provide answers to some of these other questions that we didn't get to following the webinar. So this question is, can we standardize the way the landers open up? For example, a side hatch, top hatch, square or circular opening, and can we standardize the minimum opening size?
I don't know what they mean. I don't know what we mean by standardize that. I would say that your particular offloading methodology would have some sort of standards that it must adhere to. And if you wanted to say this is what makes the most sense with this offloader, and we think this is appropriate across the gambit for this type of offloader, then I think that's helpful. If that's what is meant by side, top, hatch, I mean, those are all part of the assumptions that you're making, and the limitations that might be garnered from your particular concept, and that could be the case.
I think I would add that, there's a little misperception there that it might be that you're envisioning one particular kind of lander, like the Starship that had an opening in it. And most of the landers that we saw in those images, notional landers, were kind of open. So don't get focused in on the idea of having to reach and open a hatch and get inside something. Most of the payloads are going to be sitting on a deck or a plate somewhere attached to the open where you can just reach up and grab them. So I wouldn't be so concerned about opening sizes and being able to open things to get into the hardware that needs to be offloaded. It should be available. You just have to reach for it.
Great, thanks, Tracy. So we are now at the top of the hour. I'm going to answer one of these questions very quickly because I think it's a great question. You have a lot of detailed questions for a basic design experiment. Do we need to fill all of the question boxes if our idea can be explained more simply? So you will see that the questions in the submission form tie fairly directly to the judging criteria. So I do suggest you write something in each of those submission form questions. And when you're writing your submission form, look at the question, look at the judging criteria, and use that to inform your answer. So I'd like to extend a huge thank you for everyone that joined us today. A special thanks to the NASA folks for coming on and sharing your time and expertise with us. I know I'm really excited to see what everyone puts together for their solutions. And thank you to everyone who participated. We will be sharing the recording, we'll be sharing the slide deck with you on the challenge page in the next day or two. So stay tuned for that. All right, have a great rest of your day. Thanks, everyone.
You.